Welcome to Vantage with AI. If you thought open source video generation had hit its limit, think again. Today I'm showcasing LTX-2, a next-gen audio-video diffusion model that can generate fully synchronized video and audio locally with open weights, and it's seriously powerful.
Open source video generator that can generate up 20-second long videos at 50 FPS. And when paired with the upscaler, it can push it all the way to 4K. But this isn't just about the model, and it's about how you actually use it. We cannot just talk, we can sing too, with music and all.
Welcome to part 1. This isn't your default ComfyUI setup.
Instead of loading LTX-2 as one giant checkpoint, we spit it.
Cleaner model management and full support for both Safetensors and GGUF.
All working together.
No mess.
Best part? It's one unified workflow.
No pipeline switching, no reloading. In this video, we'll break down the workflow and the model architecture itself. And in part 2, we go deeper.
That was fun. Okay, LTX-2 comes in 2 core versions. The first is the full dev model. This is the highest quality version, and it runs at around CFG4 with 20 diffusion steps, giving you maximum fidelity and stability. The second is a distilled version, optimized for speed. This one runs at CFG1 with just 8 steps, making it dramatically faster while still producing surprisingly strong results. Lightrix also provides a distilled LoRa. When you apply this LoRa on top of the full dev model, you can run that full model at CFG1 in 8 steps, essentially combining the quality of the dev model with the speed of the distilled setup. On top of that, LTX-2 isn't just about generation. It's built for multi-stage, multi-scale pipelines. There's an X2 spatial upscaler for the LTX-2 latents, designed to progressively increase resolution across stages, exactly how you push outputs toward higher detail and, eventually, 4K workflows. And there's also an X2 temporal upscaler which works on the latent space to increase frame rate, making it ideal for smooth motion and high FPS generation without regenerating everything from scratch. All of this fits perfectly into modular pipelines, and in this workflow, I'll show how these pieces can be composed cleanly inside ComfyUI without the mess of monolithic checkpoints or duplicated models. Before we jump into the workflow, let's quickly cover what models you actually need for this setup, so you don't get lost halfway through. First up is LTX-2 itself. You can choose either the full dev version or the distilled version, depending on whether you want maximum quality or maximum speed. LTX-2 is available in BF16, FP8, and even quantized GGUF, which makes it flexible across different hardware setups. Next, you'll need the LTX-2 VAE and the LTX-2 Audio VAE. These handle the video latents and the synchronized audio generation. For camera motion and shot control, you'll also want the LTX-2 19B camera control LoRa. This is what gives you proper camera movement instead of random motion. If you're running the full dev model, make sure to also grab the LTX-2 19B distilled LoRa. This lets you run the dev model at CFG1 with just 8 steps, keeping things fast without sacrificing quality. On the text side, this workflow uses 2 text encoders, the Gemma 312B text encoder and the LTX-2 text encoder, both loaded independently for better flexibility and compatibility. And finally, to push resolution higher, you'll need the LTX-2 spatial upscaler model, which is used in multi-stage pipelines to progressively scale your output. All the download links for these models are already included directly inside the workflow, and I've also added them to the video description below, so you don't have to hunt around for anything. And while you're down there, if you find this workflow useful, don't forget to like the video and subscribe to the channel. It really helps support the content. Once these models are in place, the workflow itself becomes clean, modular, and easy to expand. So now, let's jump straight into how everything is wired together inside ComfyUI. We start with the models section. This is where everything the workflow depends on is loaded. The LTX-2 base model, all required LoRa's, the video and audio VAEs, both text encoders, and an upscaler model. Next is the prompt section. This is where you define your prompt in detail, and with LTX-2, prompt detail really matters. The more clearly you describe the scene, motion, environment, and camera behavior, the better and more consistent the results you'll get. After that comes the controls section, which is where most of the power lives. Here you define your video width and height, the length of the video in seconds, and the target FPS. This is also where you set the CFG and steps for the first sampling pass. CFG 4 and 20 steps if you're using the full dev model. CFG 1 and 8 steps if you're using the distilled model. You'll also find all the key toggles here. You can enable or disable image to video, control whether the camera control LoRa is used in sampling stage 1, enable or disable it again for sampling stage 2, and manage how motion and framing are handled across stages. If you're running the full dev model, there's also a dev model toggle. When this is enabled, the second upscaling stage runs using the distilled LoRa for much faster upscaling. If you're already using the distilled model, this stays disabled because the LoRa isn't needed in that case. You can also select if you want to use distilled LoRa for sampling stage 1, if you want fast prototype with CFG 1 and 8 steps. Whether you're loading a standard Safetensors model or a GGUF version for low VRAM systems, you simply enable the option you need and the workflow takes care of the rest automatically. Quick but very important note before you try this yourself. Text to video runs fine on lower VRAM GPUs. Even on a 12 GB card, you won't hit OOM in most cases. Image to video is a completely different story. I2V is significantly more resource intensive, and on GPUs with low VRAM, it can very easily cause out-of-memory errors. So if you're running I2V on a 12 GB GPU, you must start ComfyUI with VRAM reservation options to make sure enough memory is kept free for the latents. And when I say enough, I mean around 10 GB of VRAM reserved specifically for latents. Without doing this, I2V will almost certainly OOM, especially with the full dev model. I'll put the exact launch options I'm using in the description so you can copy them directly and avoid unnecessary crashes. Next is the Generate Latent section. This is where you upload your starting image if image to video is enabled. This block handles generating both the video latents and the audio latents required for sampling, so everything stays synchronized from the start. Then we reach the Sampler section, where the actual generation happens. This is a two-stage sampling pipeline. The first stage generates at half resolution, focusing on structure, motion, and coherence. The second stage performs a 2x latent upscaling pass, giving you the final output at the target resolution, clean, sharp, and ready for export. And with that structure in place, the workflow stays flexible, fast, and easy to extend. Whether you're doing text to video, image to video, using multi-stage upscaled runs. All right, let's actually test this model. For this run, I'm using the full LTX-2 dev model with BF16 weights, not the quantized version. Since this is the full model, I'm keeping expectations realistic and dialing things in properly for my hardware. I'm running this on an RTX 3060 with 12 GB of VRAM, so for stability, I'm setting the resolution to 720p. That gives us enough headroom to test quality, motion, and audio without running into VRAM issues. One important note. The only hardware change I made for this test is system RAM. I upgraded from 32 GB to 48 GB because the full dev model is huge and it simply wouldn't fit comfortably into my usual testing setup. For generation settings, I'm pushing this pretty hard. Video length 20 seconds, frame rate 25 FPS. This is a pure T2V run, so I2V is disabled. And here's the prompt we'll be using. It's intentionally detailed because LTX-2 really shines when you give it strong narrative and motion cues. The young African-American woman wearing a futuristic transparent visor and a bodysuit with a tube attached to her neck. She is soldering a robotic arm. She stops and looks to her right as she hears a suspicious strong hit sound from a distance. She gets up slowly from her chair and says with an angry African-American accent, "Rick, I told you to close that goddamn door after you." Then, a futuristic blue alien explorer with dreadlocks wearing a rugged outfit walks into the scene excitedly holding a futuristic device and says with a low robotic voice, "Damn the door! Look what I found." The alien hands the woman the device. She looks down at it excitedly as the camera zooms in on her intrigued, illuminated face. She then says, "Is this what I think it is?" She smiles excitedly. Sci-fi style cinematic scene. This prompt gives the model clear characters, dialogue, camera motion, emotional beats, and audio cues, exactly the kind of structure LTX-2 is designed for. With everything set, let's run the workflow and see how the full dev model performs under real hardware constraints. Okay, the results are here and they speak for themselves.
Rick, I told you to close that goddamn door after you.
Damn the door, look what I found!
Is this what I think it is?
And that's going to wrap up part 1 of this LTX-2 series. In this video, we covered what LTX-2 is capable of, how the model variants and LoRa's work, and how this advanced ComfyUI workflow lets you run text to video and image to video in a single modular pipeline with full support for Safetensors and GGUF. We also walked through the workflow structure, tested the full dev model on real hardware, and talked about the practical constraints, especially when you're running on lower VRAM GPUs. In part 2, we take this a step further. I'll be adding depth map support, integrating ControlNet, and showing how to get structured motion, better camera control, and more consistent results across complex scenes. If you found this useful, make sure to like the video, subscribe, and check the description. I'll have the workflow, model links, and launch options listed there. Thanks for watching, and I'll see you in part 2.